Homework 2.3, Linear Functions and Slopes, video number 9, due Friday, May 22nd, 2020 at 11:59 p.m. In the last couple of videos, we're going to talk a little bit more about general form and how to graph it. And I'm going to show you two techniques for graphing general form, one of which we kind of already talked about. These are the correct homework problems for this video. One way we can graph general form is to convert it to slope-intercept form, because as we've already demonstrated, if we have the equation in slope-intercept form, we have the intercept, which is a good starting point, and we have the slope, when interpreted as a rise and a run, gives us directions to how to get from the first point to the second point, and then draw our line. So let's consider the equation 4x minus 5y plus 40 is equal to 0. We're going to convert it to slope-intercept form, and then we're going to use the slope-intercept form to sketch the graph. So let's start by converting it to slope-intercept form. Just writing the equation in general form, which looks pretty but tells us nothing. How can we convert this to slope-intercept form? Remember that slope-intercept form is y equals mx plus b. In a phrase, solve for y. Any equation of a line that's not in slope-intercept form, solve for y and you'll have slope-intercept form. So we need to solve for y here, so we have to make some decisions. Decision number one, what should we move if we want to get the y by itself? There's actually two correct answers to that. Move number one, I can get the y by itself by first moving both of these terms to the other side. If I did that, what would happen to both of these terms? Since they're both positive, they would both become negative. And now every single term is negative. But that's not the only way to get the y by itself. There are two ways to get something by itself. Move everything away from it, or move it away from everything. I could also start getting the y by itself by simply moving the y term. And if I moved it, it's currently negative, and it will wind up positive. So my choice is move and make everything negative, or move and make everything positive. I wonder which one I'm going to go with. Don't get me wrong, both are correct and both will eventually work, but when you're navigating through a math problem, you have choices sometimes, and some choices are better than others based on what they do or don't create. I would like to minimize the number of negatives I have to deal with, so to get the y by itself, I'm actually going to move the negative 5y instead of moving the 4x and the 40. So we'll leave the 4x and the 40 alone. And we'll move the 5y from the left to the right, which will make it positive. And now I have one more move for getting the y by itself. Divide by 5. Now be careful. If I'm going to divide 4x plus 40 divided by 5, I have to divide the whole thing by 5. So now I'm going to get y equals y. Oh, look, the 5 and the 40, they'll reduce. But guess what? It can't, well, at least not yet. Remember the rule that I've said at least twice in previous videos, if not more. When it comes to reducing in a fraction, you can only reduce parts of multiplication problems. You cannot reduce parts of addition problems. But there was a workaround. If you want to reduce part of a multiplication problem, part of an addition problem, and your fraction has an addition problem in the numerator, I need to stress that. You can't split denominators. Then you can break this down into an addition problem by giving each term in the numerator its own common denominator of 5, and writing 4x on the first numerator and 40 on the second. Then you can reduce this fraction. Now, do you have to manually make the separation in order to write 4/5 x plus 8? 40 divided by 5 is 8. No. You can think, if I split this, the first fraction will be 4x over 5, which is the same as 4/5 x. And the second fraction would be 40 over 5, which reduces to 8. But the reason you get to do that is because you unadd those into two separate fractions. All right, so we have our slope-intercept form, and I know it looks a little bit backwards. If it makes you feel better, I'll write y equals 4/5 x plus 8. There's actually a property of equality called the reflexive property of equality. No. The symmetric property of equality, and it says something so obvious. If A equals B, then B equals A. It basically says you can reverse an equation at no cost. So anyway, here's our slope-intercept form. which means now we know the slope and the intercept. So let's sketch this. I didn't have a lot of room down here because I know I'm going to need space up here. My y-intercept is 8, so 1, 2, 3, 4, 5, 6, 7, 8. So there's 0, 8. And now let's do what the slope says. The slope is 4/5, so it's saying I need to rise 4 and run 5. So if I rise 4 and run 5, do you know where that will put me? Well, let's start with the rising. This point is up 8 and it just went up 4 more. So now it's up 12. And now let's start with the running. The original x was 0, it just went 5 to the right, so now it's at 5. So we're at 5, 12. And if I connect the dots, there we go. So you can graph general form by converting to slope-intercept form and then following suit like we did before. Start at the y-intercept, interpret the slope as rise and run, and then rise and run accordingly from the y-intercept to locate a second point. And if you were up to it, you could do it again to locate a third point, and then connect the dots. So pretty straightforward stuff.